Hey guys, so today's video is on simple probability. Now, probability is a measure of the likelihood that a specific event will occur. Probabilities have values between 0 and 1. So an event that is impossible will have a probability of 0. And then an event that is certain to occur will have a probability of 1. Often, we see our probability as a percent. When all outcomes are equally likely, the probability of an event, P event, is the ratio of the number of favorable outcomes to the total number of outcomes. Or, when you have the probability of an event, that's what that P parentheses event, it is the number of favorable outcomes over the number of possible outcomes, or total outcomes. So the number of favorable outcomes over the number of total outcomes. So we want to find each probability as a fraction in simplest form. Keyword here is in simplest form. Or a decimal, or as a percent. So we have a spinner here. It is spun once. What is the probability that the event is odd? Well, looking at this, we can see that we have 10 possible outcomes here. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know it's going to be out of 10. Now, how many of that favorable outcome are there? Well, I have 1, 3, 5, 7, and 9. That's 5 possible favorable outcomes. Instead of 5 over 10, though, we're going to simplify that. I can take a 5 from the top and bottom to be 1/2. Now, if I wanted to, 1/2 is the same thing as 1 divided by 2. I could plug that into my calculator. 1/2 is the same thing as 0.5. And then to get that as a percent, I could just take the decimal and move it over 2 times, or get 50%. These three are saying the same thing. It's just written in our different forms. All right, B, the probability that it's a multiple of 4. So that means that number has to be divisible by 4. So I have 4, of course, and 8. So out of the 10 possible choices here, 2 out of the 10 are a multiple of 4. Now I can divide the top and bottom by 2 to get 1/5. If I do 1 divided by 5, I would get the decimal 0.2. And then if I move the decimal over 2 times, I would get 20%. All right, the probability that we have a prime number. A prime number. Remember, 1 is not prime, so I have 2, 3, 5, and 7. So I have 4 possible outcomes for that one. I still have a total of 10 outcomes. I can divide the top and bottom by 2. If I do 2 divided by 5, I would get 0.4. And if I move the decimal place over 2 times, I get 40%. All right, and then D, the probability that we have an even or greater than 5. So even or greater than 5. So if I just go through and look at all my evens, I'd have 2, 4, 6, 8, and 10. And then also greater than 5. So 7 is greater than 5, and 9 is greater than 5. So if I count all the ones that would match up with that event there, I would have 7 out of 10. Luckily, that is already a simplified fraction. We don't have to divide the top or bottom. If I divide 7 by 10, I would get 0.7. Move the decimal place over 2 times, 70%. All right. Looking at number 2. A letter from the word acceleration is chosen at random. So any one of these letters could be a possible outcome in our probability. A says the probability of choosing R. So looking at this, already I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. So I know my denominator is going to be 12. And then how many of those outcomes would have R? And we'll see it once in there. So I would have 1 over 12. Already simplified, I can go ahead and divide 1 divided by 12. I get 0.083 repeating. If I move the decimal place over 2 times, I'd get 8.3 repeating percent. The probability of choosing C. Well, I see 2 C's in there. Out of my possible 12. 2 divided by 12 is 6, so I have 1 over 6. Again, I can divide 1 and 6. I would get 0.16 repeating. I can move the decimal place over 2 times. 16.6 repeating percent. Not a vowel. So remember, a vowel is A, E, I, O, or U. So going through and counting, C is not a vowel. L, R, T, and N. So I have 1, 2, 3, 4, 5, 6 out of my possible 12. I could take a 6 out from the top and bottom and get 1 over 2, which we already know is 0.5 and 50%. And then the last one for D, the probability of choosing L, R, or A. So I see A here, L, R, A. Is that it? Yeah, 4. Okay. 4 out of my possible 12. I can take a 4 from the top and bottom, and I would get 1/3. If I divide 1 and 3, I get 0.3 repeating. And then if I move the decimal place over 2 times, I would get 33.3 repeating percent. All right, for number 3, we have these cards here. We have 8 total cards. In A, we want to know what the probability that we would get a shaded card. While counting, I have 1, 2, 3, 4, 5 cards. So I would have 5 out of 8. That is already simplified. If I divide 5 and 8, I get 0.625. And then if I move the decimal place over 2 spots, 62.5%. B says the probability that it's a circle. I have 1, 2, 3 times that could happen. So I'd have 3 out of 8. If I divide 3 and 8, I get 0.375. Moving the decimal place over 2 times, 37.5%. C, the probability it's not a triangle. That one's not a triangle, not a triangle, not a triangle, not a triangle. That is 6 times. So I would have 6 out of 8, which I can take a 2 from the top and bottom and give me 3 out of 4. If I divide 3 and 4, I get 0.75. And then moving the decimal place over 2 times, 75%. D says the probability that we get an unshaded square. An unshaded square. So this one is not shaded in, and we also get a square. So we kind of have 2 things going on here. This one wouldn't count because it's not shaded in. Or it's not a square, excuse me. And this one's also not a square. And then these 2 rows are shaded in, so they don't count. So we only have 1 out of 8. Already simplified, so I don't have to do anything else with that. If I divide 1 and 8, I get 0.125. And then I can move the decimal place over 2 2 times and get 12.5%. Couple more left. All right, number 4. A date in the month of September shown below is chosen at random. So looking here, you can see that I have 30 possible outcomes. So A says that we want to know the probability that a multiple of 5 is picked. So I got a multiple of 5, here, 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 and here. All of those are divisible by 5. I can see that I have 6 of them. So I would have 6 out of 30. I can divide the top and bottom by 6 and get 1/5. When I divide 1 and 5, I get 0.2. Moving the decimal place over 2 spots, we get 20%. Probability that we pick out the third. Well, that's only going to occur 1 time out of my 30. That's already simplified, so I don't have to do anything further. I can divide 1 and 30, and I would get 0.03 repeating. And then when I move the decimal over 2 spots, we get 3.3 repeating percent. Probability that we get a date after the 14th. So that could be any one of these guys in here. Well, if I count all those up, I get 16 out of 30. I can divide the top and bottom by 2. Ooh, what am I doing here? And that'll give me 8 out of 15. I can divide 8 and 15 and get 0.53 repeating. And then moving the decimal over 2 times, I get 53.3 repeating percent. And then finally, for part D, the probability that it's on a Friday. Well, these 4 dates right here are the ones that are on a Friday. That's 4 of them out of 15. I can divide the top and bottom. Oh, 4 out of 30. Oopsie daisies. I can divide the top and bottom by 2. And I get 2 out of 15. 15, there you are. Dividing 2 and 15. 0.13 repeating. Moving the decimal place over 2 spots, I get 13.3 repeating percent. And there's that one. All right, a card is chosen at random from a standard deck of cards. Just in case some of you guys have not played cards before, there are a total of 52 cards. You start off with ace. You go all the way down to 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And you have jack, queen, and king. So each suit has 13 cards. And then there are 4 suits. So that includes hearts, diamonds, spades, and clubs. That's my little clover. It looks really bad. There's only 3. That might be it. All right. These guys are red, and those guys are usually black. So when I'm looking at the probability of picking out a black card, that's half of the deck. So out of my 52, I know that 26 of those cards are going to be black. I can divide the top and bottom by 26, and that would leave me with 1/2, which we've done this one already. It would be 0.5 and 50%. B, the probability of getting a 4. Well, each suit has a 4 card. So that means it could happen 4 times out of my 52. The top and bottom can be divisible by 4. Oh, wait, where is that? There you are. So that'll be 1 out of 13. If I divide 1 and 13, I would get approximately 0.076 and 9. So if I move the decimal place over 2 spots, I would have 7.69%. The probability of getting a diamond. Well, that's one of my suits. Each suit has 13 cards. So that's going to be 13 out of my 52. I could take a 13 out from the top and bottom. That would give me 1/4. 1 divided by 4, 0.25, or my 25%. And then finally, the probability of getting a queen or a 2. Well, each suit has a queen, so that's 4 queens. And then each suit has a 2. That's also 4 2s. So that means we have a total of 8 cards that we could pick from out of our 52. Now I can simplify that. I could take a 4 out from the top and bottom, and that would leave me with 2 out of 13. If I divide those guys, I approximately get 0.1538. And then moving the decimal place over 2 times would give me 15.38%. Okay, last one. Christina is making a necklace using beads. She used 20 red, 14 blue, 10 purple, 20 green, and 8 yellow. That's a lot of beads. She randomly chooses a bead to start the necklace. First, it'd be nice to know, all right, how many beads does she have total? So I'm just going to take the totals of each color and add them together. So I have 20 plus 14 plus 10 plus 28 plus 8. So I know my sample size is 80. There's a total number of 80 beads. So the probability of picking a blue one, all I would have to do is see, all right, how many blues are there? Well, there are 14 blues out of 80. The top and bottom can be divisible by 2, so I'd have 7 over 40. If I divide those guys, I get 0.175, or 17.5%. The probability of not being green. I could go ahead and add all those guys up besides the green ones, or I could just take 28 and subtract, or take 80 and subtract 28. No matter what, I would get 52 out of 80. I can divide the top and bottom by 4. That'll leave me with 13 over 20. If I divide those guys, I get 0.65 or 65%. The probability of getting yellow or red. So I'll take my number of yellows, which is 8, my number of reds, which is 20. I'd have 28 over 80. I can take a 4 from the top and bottom. That'll give me 7 out of 20. If I divide those guys, I get 0.35 or 35%. And then the last one, the probability of getting pink. Well, if you look at all of my colors, pink isn't on there. So it's impossible to get a pink one. So it's going to be 0 out of 80 or 0. There's a 0% chance of ever picking a pink up from there. Okay, let me know if you guys have any questions. I think there's something else on Schoology for you guys. Okay.